All right, so as of now, I think the talking needs to stop. So our topic is Pythagoras. I need people to be focused now, please. All right, so just having a look at the future ahead of us, we've actually got measurement. You don't need to write any of this down. We've got measurement coming up for pretty much till the end of term. So we're going to start with Pythagoras, which should be pretty, like, you guys have seen it quite a few times. Then we're going to move into perimeter and area, then volume and surface area, and then similarity. Now, what I need you to be aware of is that I expect that all of you have done Pythagoras, perimeter and area, volume and surface area before, and probably multiple times, and you're like, this is going to be the easiest 6 weeks of my life, okay? But I'm going to tell you that my class last year, this was the hardest topic, because if you have a look through your book, in I think it's chapter 9, there are the questions for this stuff. Each question is a page long, because it's got a picture, and then it's got a big story behind it, and it's about filling a swimming pool, which is a certain distance, and there's also this much below the surface where there's no water, and you have to actually read it and comprehend it, because this course is called applications. And so it's not just find the area of this, find the perimeter of this. Can you see these questions? I'll show you. Skip bins. You've got pools and different shapes and things. They go that's one question. Okay? So, no, just on that side. So I'm not trying to scare you. What I'm trying to say is, don't go into this thinking it's going to be simple because it's something you've done lots of times. However, the first few lessons of every topic are, because we're going to redo all those skills so that you feel confident in those skills to then apply them to the stories. But we will spend a lot of time together reading and writing through those application questions and trying to pick out the most important information, which means it's really important that you guys for this section have your calculator, but also have a highlighter so that we can actually start practicing those words. But this test was probably the hardest one last year because of how much sort of reading and interpreting you had to do. However, the skills, I think we can get down pretty easy. So let's get all the skills down and then practice the worded things. But the worded stuff is what we can actually get skills in for every topic. So as we practice applications of Pythagoras, actually being able to pull out that information is going to help you with the applications of matrices and the applications of algebra, because it's all the same skills. It's about picking out that information. And the more we practice, the better we're going to get. Now, you'll notice on here, it says test 1 was in week 5. Remember, I told you that we're going to push it back, so that's why it's moved to week 6. You will have a test in week 11 probably. Okay, so end of term, and we'll fit it in, and hopefully we'll have all this done by then, ready to go. We don't have any more investigations for this term, so it's just the one on Thursday. Flip. Yes, so that's why I'm saying, so you can, and I know that you guys asked for some practice questions. I haven't had time to do that yet, but we've still got a bit of time to get. I'll get you last year's test and I'll find you some different things. But you should be revising now for that test. So we're looking at book 1, chapter 1 and 6, book 2, chapter 6 and 7. Yeah. Okay, because pretty much what we do is we put like every topic's about 2 weeks, and we put between 2 and 3 topics into a test. So we've gone 2 topics, and then this test will have 3 topics, but they're all related to the same sort of thing. Okay, which is kind of 4 topics, but we'll see. Pythagoras fits in. Now, the reason why we choose Pythagoras to start with is because anytime we look at a triangle, in all the perimeter area, volume, surface area, you might have to use Pythagoras to actually find one of the side lengths. So Pythagoras actually comes into all of measurement if there's triangles. So we need to have this skill before we can do anything else. All right. So Pythagoras' theorem, if you haven't written it as a title, can you write it down now, please? Now there's an A apostrophe after the S because it's his theorem. There's no S after the apostrophe because, pardon? His name was Pythagoras. Yes, most of these things are named after people. Okay, it's his theory. And there's no S after that because it ends in an S. Yes. Still cold. Okay. All right, so what is Pythagoras' theorem? What is it? What's Pythagoras' theorem? Yeah. Good. Okay, so I'm just going to put it in this order, but it's fine. That is fine as well. A squared plus B squared equals C squared. That is Pythagoras' theorem. I'm assuming that you've seen that before. Now, when does Pythagoras' theorem work? What's it about? I gave you a hint before. It's about what shape? It's about right angled triangles, okay? And a right angled triangle has, so just make sure you leave some space around that because we're going to kind of put labels in here in a second. But if I look at a right angled triangle, what does a right angled triangle have? It has a 90-degree angle, so it has a right angle in it. It has a hypotenuse, okay? So the side opposite the right angle is called the hypotenuse. Now the hypotenuse is, what's special about the hypotenuse? It's the longest side. It's always the longest side. And what letter are we going to use to label that as? C. Okay, so C is the hypotenuse. It's always going to be the biggest number. The other two sides for Pythagoras, it doesn't matter which one we label A and which one we label B. So they're just the shorter sides. And you can pick and choose as you go. Now, Pythagoras' theorem only works for right angled triangles. And that's important to know because we're going to do non-right angled triangles later on. But also because we might ask you, is this a right angled triangle by giving you the three sides? And so you need to know if it works, then yes it is. If it doesn't work, then no it's not. So what this theorem actually means and the way which he discovered it was, he saw a right angled triangle. So let's just go with the easiest one, which is 3, 4, 5. He saw a right angled triangle, had a right angle in it, and he put some boxes next to it. So he looked at this and he went, okay, this is a square. It has all the same lengths as this 3 centimetres. Then he made a square here. And you guys could do this if you wanted to, but I didn't really think you'd want to get the scissors and glue out today. Although you're welcome to if you wish, yeah? So this side here is 4 centimetres, right? And then this one, which is just going to go over our notes, is 5 centimetres, right? So if we look at, we know the area of these things. If we look at this one up here and we go 3 by 3, what's the area of that square? 9. What's the area of the bottom square? 4 by 4, 16. If I add those two numbers together, what do they equal? And what's 5 times 5? 25. This is how we worked out the rule. The area of the two smaller squares will always equal the area of the biggest one. And that's what Pythagoras worked out. That's why they're squared, because it's the actual area of the squares attached to the triangles. So 9, 16, 25. Can you guys see that? Good. All right, so there are 3 different triangles which you could get in a non-calculator section. And so you may as well know them. And I always ask my classes to memorize these triangles because they're pretty much the only three we can give you in a non-calculator section because they're related to square numbers. So firstly, we need to know our square numbers. So 1 times 1, 1, 2 times 2. Okay, what's the next square number? 9. Someone else? 5 times 5. 6 times 6. 7 times 7. 8 times 8. 9 times 9. 10 times 10. 11 times 11. 12 times 12. 13 times 13. Perfect. All right. So if we look, are you serious? It's, okay, we need to maybe grow up a little bit. All right. So if we look at these square numbers, we need to go, okay, so we've already picked out 3, 4, 5 is one triangle. We're actually going to call these a Pythagorean triads. It'd be good if I could spell it. Pythagorean triads. They're definitely triangles. That's the sides of triangles which work. So one of them is 3, 4, 5. 3 squared plus 4 squared equals 5 squared. They're triangles you can actually see work with Pythagoras. Now, so you could have actually looked at this and gone, okay, so 3 squared is 9, 4 squared is 16, added together they equal to 25. Okay, can anyone see any other 2 square numbers which equal one other third square number? If we look at that list of numbers, I'll get out of your way. So look at the list of numbers. Are there any 2 which add up to a third one? They don't have to be in a row. They don't have to be, you know how 9, 16, 25 are next to each other? They don't have to be next to each other. In fact, they're not. Any 2 numbers which are in that list which add up to a third one? Nine. Okay, it has to be 2. Oh, so 9. No, that makes 34. The glass had the same one. Yeah. Pythagorean, E-A-N, triads. I'll give you a tip. The second one adds up to 100. Yep. Good. Okay, if we think about 36 and 64, it equals 100, yeah? So 36 is what number squared? 6 squared. 64 is what number squared? 8 squared. And so we know that that's going to equal, what's the hypotenuse going to be? 10 squared, because it's 100. So that's one of our other right-angled triangles you could use in a test. So it's 36 plus 64 equals 100. This one was 9 plus 16 equals 25. Okay, so 3, 4, 5, 6, 8, 10. You guys should be able to know those ones. And an easy way of remembering, if you know 3, 4, 5, what's a kind of little bit of a pattern between here and here? They're just doubled. All right, the third one is a bit trickier, and it's not a double one, but it adds up to 169. So that means the hypotenuse is going to be 13. What 2 numbers add up to 169? Yeah. 25 and 44. It is. So 25 plus 144 equals 169. So what are the two side lengths going to be on this triangle? 5 and 12. So 5, 12 and 13 is another Pythagorean triad. Yes. Thank you. Right. Okay. So those three are ones which you could get in a non-calculus section. The reason why I say that is the square root of those numbers are whole numbers which you can work out because they're all square numbers. So those numbers I wrote down the side, it's expected that you know those numbers, and when you see them, you go, they are square numbers. I know what the square root of those numbers are. Okay, so it's expected you know them. If you don't know them, can you write them down your page? Make sure you've got them there. You need to practice them because the easier you see, if you straight away, I want you to be able to see the number 64 and be like, that's a square number. It's 8 times 8. Yeah. Yeah. In a non-calculus section, yes. Okay. Any questions there? All right, so let's try finding the hypotenuse. All right, so I'm going to write steps down left-hand side and do an example on the right. So really quickly, the first steps should always be, anytime you've got a triangle question, the first step should be label the sides. And what do you think we have to label first when we're using this formula? Hypotenuse first. It doesn't matter whether you use A or B for the other ones. Okay, so label the sides. What do you think we do after that? Good. Sub in. Solve. Pretty easy 3 steps. So e.g., I've got this triangle. Now you're going to know the answer to this straight away because you learnt so much in the last 5 minutes. But we're going to actually use our formula to work it out as well. All right, so my question is going to say solve for x. What's the answer going to be? 10, straight away. Everyone should have looked at that and gone, 10, x equals 10. And even if you had no time to do your test and you couldn't do any working out, you just would have written x equals 10 because it's one of the questions you can have in your non-calculus section. It's one of the ones you need to memorize, 6, 8, 10. However, instead, I've allocated 3 marks to this question. And what does 3 marks mean? You must show working out. Okay, so we've decided I'm asking you, you must show working out. And in your investigation on Thursday, there are some questions which are worth 3 marks, which don't say show you working out, but it says solve for it. You have to show working out to get full marks. So always look at the mark allocation. Okay, if you get 3 marks, if it's worth 3 marks, you must show working out. So this question I've got, yep, it's worth 3 marks. And you're like, okay, I know it's x equals 10, but I have to actually show that x equals 10. So what am I going to do? Come on. Someone other than Jordan. It's very easy. The steps are there. They're on the board. What are we going to do? Label the sides, okay? So which one is C? The X, okay? The other one I usually just go left to right, so A and B. Okay? So I'm now going to go, okay, I've got my formula, and I'm actually going to show you 2 different ways of doing this. There's the way most people do it, there's the way I like to do it. It's up to you which way you would rather, but I'll show you some reasons why I choose the second way. So the first way is I write my formula, a squared plus b squared equals c squared, and then I sub them in. So a is 6 squared plus 8 squared equals x squared. Now, be careful there, because if you leave it as c, and you end up writing your answer as C equals 10, you're actually going to lose marks because the question's asking you for X equals. So if you sub in the letter at the same time as you sub in the numbers, you're not going to get stuck like that. So then I've got 36 plus 64 equals X squared. So 100 equals X squared. But my problem is I've now got X squared there. How do I get it to just be X? What have I got to get rid of? Got to get rid of the squared. What's the opposite of squared? The square root. So I need to go square root of 100 equals X. So X equals 10. And if you have units, which I didn't, you would put the units in. Can everybody see that? Now, if it's the square root of, for example, don't have to write this down, but if I said the square root of 123, if that's what it ends up being, not this question, a different question, if it ended up being the square root of 123 and it was in a non-calculator section, what would you do? Yep, just leave it like that, okay? That's still completely correct. It says the square root of 123. So if it's in a non-calculator section, you can leave your answer with a square root sign. However, if it is a square number, we expect you to simplify it down. Does everybody understand that? All right, so my way on the right-hand side is actually to rearrange the formula before you sub in the numbers. So instead of, because we're trying to find C, I want to get C by itself. So if I want to get this C here by itself, what have I got to get rid of on this side? The squared sign. So what I'm going to do is I'm going to move that to the other side and make it a square root sign. So I'm going to rearrange the formula so it starts like that instead of with the equals squared. And what that means is when you're using your calculator, this next line is all you have to put into your calculator instead of having to do about 2 different steps in your calculator. So then I can put in 6 squared plus 8 squared equals C. Now that line of working out is the most important line. In the other one, it's this one. That's what's going to get you working out marks. The rest doesn't matter. So if it asks you for working out lines, this is the line we're asking for. The formula with the numbers in it. This is the minimum amount of working out you could show. So then because of that, all I actually have to put into my calculator is the square root of 6 squared plus 8 squared, and I could get my answer in one line instead of having to do it a different way. Just be careful to make sure the square root sign goes all the way across the whole thing, the plus bit as well. So then I've got square root of 100 equals C, so 10 equals, oh, and what have I done wrong? So I've got 10 equals C. Have I finished my answer? What have I done? Good. Therefore, X equals 10. And if you do that, that's fine. Just remember that at the end, make sure you're actually answering the question. So the question asks for X, your answer has to be X. Emily? Yeah. Any questions about that? Do we need to do another example or are you all good? Okay. What I'm going to do is I'm going to get you to do some questions and then we're going to come back and do one other little bit of notes. So we're looking at exercise 7A in your book, unit 1. Everything's in unit 1 for the rest of the term. Okay, questions 1 to, hang on, got to find it. Sorry. One to 6, and then also 8 and 11. So questions 1 to 6, and then leave 7, do 8, leave 9 and 10, and do 11. Now I'm going to give you about 6 minutes to get started and do as much as you can, and then we're going to do some other notes. Could you write that down? I'll put